Now we're going to talk about the unit circle with coterminal angles. So what you need to remember is that with our unit circle, I can continue going around and getting coterminal angles. So for example, we've talked a lot about if I did 180 and I did 540, the difference between the two is that one I went around 1.5, whereas the first one I ran around a half, so the revolutions differ. So your coterminal angles are where the revolutions differ. So you can use your coterminal angles that are in between 0 and 360 or between 0 and 2 pi that give you the same exact answer as the one that is the coterminal angle. Okay? So for example, if I took 60 and I did 360 plus 60, which gives you 42, or 420, sorry. So 420. 420 would have the same sine, cosine, and tangent values as 60 degrees. Okay? So we're going to start off the same way. So for 600, I want to find out what the coterminal angle is for 360. So remember, if we look at coterminal angles, I'm going to take the one that I originally have, so 600, and I'm going to subtract off or add, depending on if it's positive or negative, a revolution. So I get 240. So this is the same spot as 240, but I've gone around one full time and an extra to 240. Okay, so 240 is in your third quadrant. Okay, so now what I'm going to do, the cosine of 600 is the same value as the cosine of 240. So I'm going to look at the point of 240. The x value is what I want because the cosine is the x. So the cosine of 600 is going to be -1/2. Okay. If I want to look at the tangent of 810, I'm going to do 360 minus 810. Or 810 minus 360, sorry, I said it backwards. So I do 810 minus 360, that gives you 450. Okay, notice this is still over 360, so I'm going to subtract another revolution to get it in between 0 and 360, so I know exactly what quadrant it's in. So I subtract another 360 and I get 90. So this means that I've gone around one full time, a second full time, and then to 90. Okay, so the tangent of 810 is going to have the same value as the tangent of 90. Notice your point at 90 is 0, 1. Okay, so our tangent is going to be y over x. So 1 over 0. Remember, you can't divide by 0, so I'm going to call it undefined. Okay, let's look at 405. Well, 405 is past 360. So I do 405 minus 360, and that gives you 45. So I went one full revolution, it's positive, so it's going counterclockwise, and then to 45. So your reference angle is 45, or your coterminal angle is 45. Okay, so I'm going to look at this point in the first quadrant. And we're doing the sine. Remember, the sine is the y value, because you think of y sin because it's extra fun. Take your extra fun and go. So the sine is the y value, which is root 2 over 2. Okay. Now, radians, I think, are a little bit easier because you can shortcut finding, you can shortcut it a little. So what I say, you don't have to subtract 2 pi, that's how you shortcut it. Remember how we talked about yesterday how if it was something pi 6, it had a 30-degree reference angle, and if it was something pi thirds, it was a 60-degree reference angle, and something pi fourth was a 45-degree angle? Well, that's true still for your coterminal angles. So 17 pi 6 has a reference angle of pi 6. Okay, so all I need to do is figure out which quadrant this is in. Well, we do that the same way that we've done before. You can either do, how many times does 6 go into 17? Well, 6 goes into it 2 times, and I have 5 left over. So I have 2 and 5/6 pi. Or you can do it in your calculator and do 17 divided by 6 and get 2.83. So if I draw this, I go around 1 full time and to 8.3, so this is 0.5, this is 3, so somewhere in here. And I have a pi 6 reference angle. Remember, your pi 6 is your 30-degree reference angle. So this is going to be your 30-degree reference angle in your second quadrant. So 17 pi 6 is the same thing as 5 pi 6. Okay. The other way I look at this is that 17 pi 6 is just 1 off of 3 pi, because if I had 18 pi 6, this would reduce to 3 pi, right? So I'm 1 shy of 3 pi. Well, remember that your odd pi's are on this side, so 1 pi, 3 pi, 5 pi, 7 pi, 9 pi, and continuing on. And over here are your even pi's, 0, 2, well, 0 is not even, but 0 is over there. So 2, 4, 6, 8 pi, all of those are on this side. So 3 pi is going to be just shy of 3 pi, and since it's a pi 6th, it's going to match with this pi 6. So there's 2 different ways you can look at it. Actually, I think that was 3, but whatever. So then we're looking at the sign. So the sign is the y value, because y, sin. So the sign is the y value, so it's a positive 1/2. Okay. 25 pi thirds, I already know before doing anything that it's going to be a pi thirds reference angle, which means that it's also 60 degrees. Okay, so I'm going to be looking at my green ones on my paper. Okay, so 25 pi thirds, I say how many times does 3 go into 25? Well, 3 goes into 25 8 times, sorry, I was thinking 6 times 4 is 24. 3 goes into 25 8 times, and I have 1 left over, right? So I go to 8 pi, so here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, and then 1 left. So I'm in the first quadrant again, okay? If you do 25 divided by 3 on the calculator, I get 8.3. So I would go around to 8 pi like we did, lots of circles around. And then I would go up past it just a little bit. Okay, so I'm going to be in the first quadrant with your pi thirds, which is your 60-degree reference angle, which is the green one on my paper. So I want the cosine of 25 pi thirds. The cosine is the x value, so it's 1/2. Okay. Let's try the last one. 15 pi fourths is a pi fourths reference angle. Okay. So if I do tangent of 15 pi fourths, I think to myself, how many times does 4 go into 6? I keep saying parts of things that I'm thinking. 4 goes into 15 3 times, and I have 3 left over. So it's 3 and 3/4 pi, or it's 1 pi 4 shy of 4 pi, because 16 pi fourths is 4 pi. Okay, so on your radians that are on the unit circle, so anything pi 6, pi thirds, or pi fourths, if you go up by a number or down by a number, you're either going to get an even pi or an odd pi. So I should get like 3 pi or 4 pi or 2 pi. And then if it's 1 shy, then I go above. If it's 1 more, I go below. Okay, if it's 1 shy of the even, I go 1 less here. If it's 1 above, I go up. Okay. If I do 15 divided by 4 in the calculator, like we've done before, notice it's 3.75. So I go to 3 pi, so here's 1 pi, 2 pi, 3 pi, here's 3.5, 3.75 puts me in the 4th quadrant. Okay, or notice this would be 4 pi and I'm just shy of 4 pi. Okay, so I'm going to look at the pi fourths in the 4th quadrant. This is going to be my point. I want to find the tangent. Our shortcut for the tangent is the top of the y over the top of the x. So I do the top of the y, which is root 2, over the top of the x, which is root 2. The y value is negative, so negative root 2 over 2 is a negative 1. Okay? That's how you do it with your coterminal angles.